Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about carboxylic acids and its derivatives, lecture 5. So this will be highly useful for BSc chemistry students under CBCS syllabus. So please think for innovation, be creative, learn everywhere, anytime and help to learn others. So this is the unit carboxylic acids and their derivatives, unit 4, CC6 paper in semester 3. Today we are going to talk about mechanism of acidic and alkaline hydrolysis of esters, Claisen condensation, Dieckmann reaction and Reformatsky reaction. So this is the prerequisite knowledge that is required for mechanism. So we all know the reactant is converted to product in presence of reagents. So how that reactant is converted to the product in the presence of reagent, that is known as mechanism. So what mechanism tells us? It shows the movement of double-headed arrow. Double-headed arrow movement means movement of both the electrons. How the bonds are broken and new bonds are formed, leading to formation of product, which may be multi-step or one-step process. So suppose this AX bond is broken heterolytically, and the atom on which this bond is breaking, that gets negative charge with both the electrons, that becomes nucleophile, and the other atom gets electrophile. And by principle of mechanism, always nucleophile will attack to the electrophile. So nucleophile will always attack to electrophile, giving rise to nucleophile electrophile bond, that is AX bond. Similarly, when this bond is broken, so you generate electrophile and nucleophile, vice versa. So let's talk about mechanism of acidic hydrolysis of ester. So this is the ester. The formula is CH3COO C2H5. So this will be hydrolyzed in presence of catalyst H plus and water, giving rise to acid and alcohol. So the ester, this carbonyl has lone pair of electrons. So this can act as nucleophile. It will attack to the electrophile H plus. So as a result, you get this protonated form of this hydroxyl group. So this can undergo resonance. So this CO bond will break on O plus. So as a result, you generate a carbocation. So once you generate this carbocation, so water can act as nucleophile. So water lone pair can attack, oxygen lone pair can attack this electrophile center C plus. So you generate this intermediate where you have protonated form of water. Then again this oxygen will attack to this hydrogen and this OH bond will break on O plus. So as a result, you get this intermediate. So here the transfer of proton take place. And again this CO bond will break on this O plus, resulting the neutral water molecule. And again water will take this proton and this OH bond will break on this oxygen. So as a result, you end up with this acid, plus again you get this acid catalyst back. Similarly, base hydrolysis of ester. So here we take the base OH minus ion, and this is the structure of ester. So resulting the acid and alcohol. So OH minus ion can act as nucleophile, so it will attack to this carbonyl carbon and this CO bond will break on oxygen. So resulting this tetrahedral intermediate. So when this O minus will come back, it will kick out or this CO bond will break on oxygen. So as a result, you get this carboxylic acid plus C2O, C2H5O minus. This C2H5O minus again can take the proton from acid, resulting the anion. And upon acidic workup, you get the carboxylic acid plus alcohol. The next is Claisen condensation. Claisen condensation is the C-C bond forming reaction that occurs between two esters or one ester and another carbonyl compound in presence of a strong base sodium ethoxide, resulting a beta keto ester or beta diketone. So the intermolecular or self condensation of two esters having one alpha hydrogen atom. So this is the ester where here you have with respect to this ester group, this is alpha carbon. So this two equivalent of this ester can undergo condensation to give rise to, in presence of the base C2H5O minus, giving rise to beta keto ester plus alcohol. This is the mechanism. So we have the base C2H5O minus. So this C2H5O minus will take this proton from here, and this CH bond will break on this carbon. So as a result, you generate a carbanion. Once you generate this carbanion, it will attack, this carbanion will attack the carbonyl carbon of other ester, and this CO bond will break on oxygen. So as a result, you generate this intermediate. So when this O minus will come back, it will kick out OR as OR minus. So as a result, you end up with beta keto ester. So here is one problem for you guys. So suppose we take this carbonyl compound and this ester. Okay. So you will end up with this diketo compound. So please write down the mechanism for this one. So this is otherwise known as mixed or crossed Claisen condensation reaction. The next is Dieckmann condensation reaction. So the ester of C6, C7 or C8 dibasic acid undergoes intramolecular condensation to form cyclic ketone derivative in presence of sodium or sodium ethoxide or potassium tertiary betoxide. So this diester compound in presence of sodium ethoxide giving rise to this beta keto ester. So with respect to this ester, this is alpha and this is beta. So you get this ketone, cyclic ketone derivative. So here this alpha carbon with respect to this ester, this alpha carbon is a hydrogen, has acidic in nature. So this C2H5O minus will take this proton, and this CH bond will break on this carbon. So you generate a carbanion here, and once you generate this carbanion, it can act as nucleophile. So this C minus can attack this carbonyl of other ester, and this CO bond will break on oxygen. So you will end up with this cyclic product. When this O minus will come back, it will kick out OC2H5 as OC2H5 minus. So as a result, you get this beta keto ester. So in conclusion, if you start with 1,6 diester, it will give 5-membered cyclic beta keto ester. So if you start with 1,7 diester, you will end up with 6-membered cyclic beta keto ester. The equivalent intermolecular reaction is called Claisen condensation reaction. Then the last one is Reformatsky reaction. So the reaction of a carbonyl compound, that is aldehyde or a ketone, and ester of alpha bromo acid in presence of zinc metal to form a beta hydroxy ester after hydrolysis. So this reaction is known as Reformatsky reaction. So this is aldehyde or ketone plus zinc plus this is the ester of alpha bromo acid. Okay, so with respect to this ester group, this is alpha carbon. So this is alpha bromo acid, ester of alpha bromo acid. So you will end up with this organo zinc bromide complex. So this upon hydrolysis, you will end up with beta hydroxy ester. So now we will talk about the mechanism. The ester of alpha bromo acid upon reaction with zinc, so that becomes ZnBr. So this is just like a Grignard reagent, just like RMGX. So you get C minus ZnBr plus. So once you get this, so this C minus can come back here, and this CO bond will break on oxygen. So you get this enol form. So this is resonance stabilized. So this C minus can again act as nucleophile. So it can attack to the aldehyde or ketone of a carbonyl carbon, and this CO bond will break on oxygen. So as a result, you get this organo zinc bromide complex, and this upon hydrolysis you will get beta hydroxy ester. So please subscribe to our channel Chemistry Live UGPG. So this is also available in the website www.chemistryliveugpg.com. So this is the channel Foundation Chemistry AB for class 11th and 12th students. This is also available in the website www.foundationchemistryab.com. So this is a simple step towards e-learning, making life better. Thank you all for learning.